In this example, we're going to solve this linear system using elimination. So the first step to elimination is to make sure that all of the equations in the system are written in standard form. So we have the x and the y, and then we have equals, and then we have our constants over here on the right side. So it looks like both equations are already written in standard form. And the reason we like this is because we have like terms that are vertically aligned. So our x's are together, y's are together, and then our constants are together on the other side. So the next step in elimination is to locate kind of a viable variable, one of these variables that will work well in eliminating. So in order to eliminate a variable, we're going to add these equations together. So we need the coefficients of the variables to be equal in number but opposite in sign. Well, it looks like our x's have opposite signs. One's positive, one's negative. Also, our y's have opposite signs. One's negative and one's positive. The problem we see here, though, is that the numbers are not the same. For my x's, I have 2 and 4, and for my y's, I have 5 and 9. So in order to accommodate this idea of equal in number but opposite in sign, in order to cancel one of the variables out, I need to use our multiplication property of equality, which says that whatever I do to one side of an equation, and specifically multiplication, I also need to do it to the other side of the equation, and the two sides of the equation will remain equal. So we're going to take this first equation and we're going to adjust it. And the reason we've chosen the first equation, and very specifically we're going to look at the x's, because 2 is going to be a factor of 4. So if I take 2 and I multiply it by 2, I'm going to have a positive 4, which then will cancel nicely with this negative 4. So what I'm going to do, I'm going to take this first equation and I'm going to multiply both sides by 2. So the 15 is multiplied by 2, the negative 5y, and the 2x. So let's go ahead and rewrite that first equation and see what that looks like with all of the terms multiplied by 2. 4x minus 10y equals 30. Now if I was to just rewrite that second equation left unchanged, I see that my x's now are ready for elimination. I have a 4x and a negative 4x. So when I add these two equations together, my x's are going to cancel, and that's the goal. So now we have negative 10y plus 9y is negative y, and a 30 minus 31 is negative 1. So when I divide both sides of the equation by negative 1, my y value will be a positive 1. So now that I have the value for one of my variables, I can plug it back into one of these original equations to find the value for x. So let's go ahead and just use this first equation. 2x minus 5y, and the value of y is 1, and that equals 15. So 2x minus 5 equals 15. When we add 5 to both sides, we'll see that 2x equals 20. A quick division by 2 will show us that the value of x equals 10. So as I write the ordered pair, it's going to be the x value is 10 and the y value is 1. And this ordered pair 10, 1 functions as the solution to this linear system. And we solved it using elimination.